right, so I just have some possible answers that you guys might have come up with when you were doing the little turtle activity. Um, so just I noticed like the x-axis is time, the y-axis is distance from the water. So if you have a horizontal line, the turtle's not moving. The steeper the graph, the faster the turtle moves. A negative slope, the turtle's going to move backwards. So those things might have been something that you noticed. Um, but in this case, this turtle situation, make note that the distance is a function of time. Now, this is an introduction to functions. This is kind of gets you thinking about functions. Okay, and then we have a situation where you have the graph and you're supposed to write a story about it. So you can check yours with mine. All right, number three is something I don't feel like you do a whole lot with in Algebra 2, but we do quite a bit with it in pre-calculus and in calculus. But we want to know how far away from the water the turtle was after 8 seconds. So we're going to evaluate this function from the graph. So you just go to where x is 8, and then that looks like that's going to be 10. So it's going to be 10 feet. And a lot of times that we would write that in function notation where d of 8 is equal to 10. All right, and then we know that after 5 seconds, the turtle is 4 feet away from the water because that's the y value at that at 5 seconds. So to write that with function notation, we would say d of t is 4 when t is 5. Okay. And then I love this one where the turtle like became two turtles. So this situation right here is not a function because the turtle cannot be in two places at one time. And one thing you guys may remember from algebra is that a function must pass the vertical line test, and this one would fail the vertical line test. And each input can only have one output whenever it's a function. Right. And then is it possible for the turtle to be 5 feet away from the water multiple times? Absolutely possible. So it is okay for functions to have repeated outputs. So repeated outputs are allowed. Great. Now that's just an introduction to kind of get you comfortable with working with functions. And now we're going to kind of formalize that information on the backside. Right, so a function is a relationship between two variables where one variable determines the other. I just saw that there's a typo. She determines. One variable determines the other. Right, now function notation is like this. It's f of x equals y. So f is just going to be the name of the function. X is the independent variable. Also called the input. And Y is the dependent variable. Or the output. So remember that each input can only have one output, or can have only one output. So that would be like the turtle being in two places at once. It can only be at one place at a time. Okay, and then one more thing we're going to fit in this box is to evaluate a function means to find the output for a given input by plugging the input into the function. Okay. So in this first example, we're going to determine whether the relation represents a function. And so for you to have a function, each input must have exactly one output. So on this first one, for example, I noticed immediately that 0 is paired with -2, and then 0 is also paired with 7. Like that cannot happen for a function. That's like the turtle being in two places. So no, this is not a function. 0 has two outputs, and that cannot happen for a function. All right, B is a different kind of situation. So B asks, is X, or is this the function if X is the height of the student and Y is his or her age? So this isn't so much um, is there going to be a repeated output? It's more like, is there a relationship to the height and the age of a student? And so we're talking about students from kindergarten to college, I guess. And so this would actually be no. The height isn't associated with a particular age. Or with one particular age. So some 6-foot people are young, and some are older. So you can't have a function that tells you, like, if you're 15 years old, this is how tall you are. So that's what he's talking about. Okay, and then C is the number of minutes on a treadmill, and then Y is the number of calories burned. So this is definitely a function. at any moment during the workout, you can have burned only 1 caloric amount. I'm going to go back up and talk about B again because I felt like I didn't explain that well. We can think about it like one outfit. So one 15-year-old can be 6 feet tall. One 15-year-old could be 5'9". So an age can have multiple outputs. Oh, I've got that backwards. Sorry. X is the height of a student. So the height, like somebody who's 6 feet tall, could be 15 or it could be 16. So I think it was okay the first time I explained it. Sorry. All right, let's look at D. So for D, we have this graph, and we want to know if it's a function. And this goes back to the vertical line test. So we would say no, that this function fails the vertical line test. And you can take individual, like 4 is paired with -2 and 2. That cannot happen. All right, so let's talk about evaluating functions. I feel like this is something you probably remember from algebra, but if we have this function g of x, which is x squared plus 5, and we want to evaluate it, we are just going to take those values for x and we're going to plug them in. So for a, we're going to plug in 2. So where the x is going to become a 2, and 4 squared plus 5 is, 4 plus 5 is 9. Now, be careful with the negatives. We do want to square the negatives, so that's 49 plus 5, which is 54. Now, see, it's kind of weird. We're just going to take that x and we're going to turn it into a t. But there's nothing to do but just write it. All right, for D, it's even weirder. We're going to take that x and turn it into a smiley face. So we'll square it and add 5 to it. All right, and then for E, we're going to take that x and turn it into an x plus h. So we're going to square it and add 5 to it. All right, so that's evaluating. And then the last part, we're going to kind of interpret this function. So we're going to let P of T represent the number of people in a store T hours after the store opens at 6 a.m. And we're going to interpret the following statements in context. So P of 2 gives us 83. All right, so this 2 is the number of hours since 6 a.m. So that's going to be 8 a.m. And then the 83 should represent the number of people in the store. So at 8 a.m., there are 83 people in the store. B is a little different. It tells you that P of 3 is equal to P of 6. So to me, 3 means 3 hours since 6 a.m., so it's 9 a.m. And then 6 hours since 6 a.m. is 12 p.m., so noon. So there's going to be the same number. They're going to be equal. So it would have the same number of people in the store. So at 9 a.m. and you can say 12 p.m. or you can say noon. There are the same amount of people in the store. All right, and then the last one, P of L, is 121. So L can't give us an exact time, so we just kind of have to leave it kind of generic. So you would say after L hours, there are 121 people in the store. Okay. All right, so this is our first assignment out of the book. So I don't know if any of you bought the book, but there's a digital book, and I also am going to I posted the pages for the specific lesson in Classroom, so you don't have to go hunting. But on page 14 through 18, I want you guys to do 2 through 10 even, and then 16 through 22 even.